In this video, we're going to evaluate the integral of the square root of 1 plus cosine of x. And there's not much you can do with the integrand right now, the way it's given, at least to evaluate it. But we're going to use a trick that we've used in other videos, or other problems I should say. And I'm going to multiply the integrand by 1. This would be 1 minus square root of 1 minus cosine of x. Okay. Inside the interval here, and I can make this a 1 here, doesn't change it, and I'm multiplying the numerator and denominator then by the square root of 1 minus cosine of x, and that doesn't change it because all I'm doing is multiplying by 1. Radical 1 minus cosine of x over radical 1 minus cosine of x, that's equal to 1, so that doesn't change it. We're going to come back over here then and rewrite this. So multiplying right here, square root and square root, so I can multiply the radicands here, and that's inside there. I'd get 1 minus cosine squared of x. That's the sum and the difference of the same two terms, so this gives me the difference of the squares. 1 squared is 1, and here I have minus cosine squared of x. But this you should recognize as sine squared. That's equal to that, because we know that sine squared plus cosine squared equals to 1, or cosine squared plus sine squared is equal to 1. So I can replace the 1 minus cosine squared and the radical by sine squared. So basically when I multiply these two out, I wind up with a square root of sine squared, which is equal to sine of x. And we won't use absolute values here since we know we're just integrating here, and we can consider the angle to be at an acute angle, and everything is positive for the trig functions. So what I'll do then is in the numerator I'll put sine of x, in the denominator I still have the square root of 1 minus cosine of x, and this is dx. So that becomes the integral that I want to evaluate. So to proceed from here, I'm going to use a standard U-substitution, so I'm going to let u equal to 1 minus cosine of x. Then du would equal to the derivative of 1 is 0. The derivative of cosine of x is minus sine of x, but then we have the negative here, so it becomes a positive sine of x. And this would be dx. I'll come back over here then. I want to transform this to an integral involving the variable u. So notice here in the numerator I have sine x times dx. Okay, so here I have sine x dx, that's du. So this would be du here. And then in the denominator, I got the square root of 1 minus cosine of x, so that's my u. So this will be the square root of u. I'm going to write that as u to the 1/2. Easier to integrate. And then I take this to the numerator. This becomes the integral of u to the negative 1/2 du. Now it's basic integration with respect to u. So I add 1 to the negative 1/2, I get 1/2, and then I divide the coefficient 1 by 1/2. This becomes a 2 here in front, and this will be u to the 1/2. Again, added 1 to the minus 1/2, and I got the 1/2, divided the 1 by 1/2, I got 2. This is plus the constant of integration. This then will be 2. And then u to the 1/2, that's the, again, 1/2, that's the square root. So it's the square root of what? 1 minus cosine. So this will be the square root. Go back to the original variable then. U is 1 minus cosine of x. And then plus the constant of integration. So final answer then is 2 multiplied by the square root of 1 minus cosine of x plus the constant of integration. Thanks for watching. We'll see you next time.